Okay, in Module 3, Lesson 19, you already started working on the opening exercise, which is a review from yesterday's lesson. So using your straight edge, the rulers are at your table, you make your line segments between the 2 points. The ordered pair of the top point is 4, 4. The ordered pair of the bottom point is 4, negative 4. Since our x coordinates are the same, which is why it runs through parallel to the y-axis, and it cuts through the x-axis at 4. Our y coordinates are different. So if I want to find the distance, I have to find the absolute values of the y coordinates. The absolute value of 4 is 4, and the absolute value of negative 4 is 4. But now I have to decide whether to add those together or subtract them. What am I going to do and why? Should I add those two absolute values together? This is 4, and this is 4. But I want to know the whole distance of that whole line segment. I can see what to do when I draw it on my coordinate plane. But just looking at the ordered pairs, how would I know what to do? I'm going to add them together because they are on different sides of the axis or different sides of 0. So 4 plus 4 is 8. So the length of that line segment is 8 units. Are there any questions on that? Okay. Let's take a look at number 1. Draw those 2 points on your coordinate plane, 4, 5, and 4, negative 3. And draw the line segment between those points. And how long is that line segment? Now here's that key word, explain. A lot of you are forgetting to explain your answers when it's in the directions. So we have our x and our y axis already labeled. So 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. And we always label our points with the ordered pair. And then I use a straight edge to connect the points. So those are now my endpoints for my line segment. So far, so good? Yes? My x coordinates are the same. So I can look at my y coordinates, the 5 and the negative 3. So the absolute value of 5 is 5. The absolute value of negative 3 is 3. Since they're on opposite sides of 0, I add the two distances together, and now I know that the distance of that line segment is 8 units. In fact, I'm going to go ahead and label that with a big 8 so that I know the length of that side of that line is 8. Okay? You could count the boxes, but sometimes we're going to be working with really long line segments. Or remember the other day how we changed the scale on the y-axis and made each box worth 10 or 20 or 0.2. So sometimes counting those boxes could trip you up if you're not sure what the intervals are on your axis. If it's really big, you don't want to count that high. Or if the boxes are really tiny, you're going to go cross-eyed and you could lose count. That's why looking at the ordered pairs and doing it mathematically instead of counting is another strategy that you can use.
At first I tried to count them, but then I got inside.
Yeah, you could go a little cross-eyed or count something twice. So that's why it's good to actually look at the ordered pairs and let that help you. So when we looked at them, 5 and negative 3, I just know 5 to the x coordinate is 5, and then another 3. So 5 and 3 is 8. I think it's easier to add. Maybe that's just because I'm old and my eyes are starting to go. It's hard to see. Yes?
How do we, figure out, where the negative is on, the first or the last number? Because I wasn't that.
They gave us those points in the directions.
You know, the whole, thing, if you were to, find, a point, which side would have, a negative,
Well, anything below the x-axis is a negative because this is a number line. And that's something you missed when you were absent. So if you come up to extra help, we can go over that or watch the videos on the blog, okay? Okay, so now step 2. Draw a horizontal line segment. So everybody show me which way is horizontal. Which way is horizontal? This way or this way? Side to side, like you're looking at the horizon. The sun sets on the beautiful horizon across the tops of the trees. That's your horizon. So your horizontal line. Okay, so starting at 4, -3, which is right here, they want us to draw a line that has a unit of, draw a line that has a length of 9 units. So hold on, let's just look for a minute. 1, 2, 3, 4, 5, 6, wait, 7, wait, not, ugh. What would it be? What's changing when I make a horizontal line? Is my x coordinate changing or is my y coordinate changing when I'm moving horizontal? What's going to change when I'm moving horizontal, my x or my y? If I move this over, what would change? Would that be a 5 or would that become a -4? What changes, everybody? The x. So if my x coordinate is going to change, and I'm going to go 9 spaces, what would it become? Starting at 4, adding 9 more spaces, what would it become? If I'm at 4, and I want to go 9 more spaces, where would I be? 13, -3. But that's kind of like gross, because that's kind of like not on my coordinate plane. Do I have another option? I don't want to use 13, -3. That's possibility, 13, -3, if I moved to the right 9 spaces. But we want to stay on our coordinate grid. Did it say I had to go to the right? No. Suppose I go to the left. If I start at 4 and I go 9 spaces, where would I be?
-5.
1, 2, 3, 4, 5, 6, 7, 8, 9. We would be right here. -5, -3. -5, -3, and that's if I went to the left. So to answer the next question, which is on the back of your note, you should have both answers written down for number 2 because it asks for all possibilities. So for number 2, you should have both ordered pairs written down.
Can we also go down?
Can we go down? Can we go down? Why not? Right, it said horizontal. So that key word tells us we have to stay left and right. We can't go up or down. Good question. On the back of the page is the next part of the question. Which ordered pair do we want to use? Do we want to use the 13, -3, or do we want to use the -5, -3, and why? What do you think? We want to use -5, -3. Why? Why did we say we wanted to use that one? Right. Well, not on the number line. Because why? It's on what? The coordinate plane. Okay, so that should be your answer on the back of the page. So on the back of the page, you're writing this down. Okay. So now for number 3. We have our original points. What was our first point? Remind me so I can label it. 4, 5. 4, -3. Then we had -5, -3. Hey, that kind of looks like the beginning of something. What does that kind of look like it could be? Well, could it be a square? What was the length of this side? We said the length of this side was 8. What was the distance of the other line? How many units to the left did we go? We went 9 units to the left. So can that be a square? Close. What can it be? It's close to a square, but not. A rectangle, absolutely. So for 3A, find the coordinates of the fourth vertex of the rectangle. What does that mean, vertex? Is that like in black holes where they traveled through? No, that's not a vertex. What is a vertex? It's a vertex.
Isn't it vertex like a corner?
It's a corner. It's where the two line segments meet. So if I use my ruler to extend my line 8 units, and then I extended this line 9 units, because a rectangle has to have opposite sides that are equal. Get back to your first page of your notes. I like the way some of you are using your ruler. So what would the coordinates? What would the ordered pair be for our new vertex? What would they be? Pick up your head, please. Let's participate.
-5, 5.
-5, 5. And they want you to explain how you got your answer. So you could say you used the same distance. You knew that the distances in a rectangle had to be the same. It asked you how you used absolute value. Well, using absolute value, we knew this side was 8, so we knew that the other side also had to be 8, because that's what a rectangle is. It would be great if you were writing some sort of answer down for 3A. Okay? We're actually going to skip 3B. 3C we already did. I had you draw the sides. Okay. So here's what your completed picture should look like. So for number 4, using the vertices and the length of the line segments, what would be the perimeter of that rectangle? First of all, perimeter, Blast Elementary School, what does the perimeter mean? What does perimeter mean? I'm really concerned how many students are not raising their hands right now. What is perimeter? Absolutely, the length of all the sides, all the way around the shape. So how do we find the perimeter if we want to find the length or the distance all the way around? Add them all up. So let's add them up to find the perimeter. 8 plus 9 plus 8 plus 9 equals what? What is it? Excuse me? How do we label perimeter? Think about you learned this in science from Mrs. Scully. How do you label? Perimeter is just distance. Just a straight line. Even though it bends and goes around, it's one-dimensional. So how do we label that?
Cubic.
Cubic would be used for volume. Squared is used for area. When we have other dimensions to it, this is just a straight line. If I was going to go from here to here, how many feet would that be? That would just be feet, or inches, or miles. It's just a straight line. So we're just going to label it units. We're not squaring it. We're not cubing it, because it's just a straight line. Okay, area. How would I find the area of that? Elementary school, science, you've done this before. How do I find the area? Multiplication. What am I going to multiply? 8 times 9 times 8 times 9. I multiply all the sides together. Is that what I do? You're all shaking your heads at me like I'm crazy. What do I do? I just do length times width. So that's 8 times 9, which is 72. How do I label this? Because now I don't have just the distance, I have the entire surface, the entire area, all of the squares. So how do I label that? All the squares in it are included. 2 different directions. All the squares are included. How do I label it? Units squared. Question. Is that the same thing as that? No, this means something totally different. Please don't ever do that. That means something totally different. Yes. You can write it out as square units. Those mean the same thing. As long as you're squaring the units, you're not squaring the number. Yes.
Can you do this, like for number 4? Can't you just do 8 times 2 and then 9 times
You
2
could do that because the two, well, because both sides are the same, it would work. That won't work if your sides are different distances. If you had a shape that looked like this, where this side is different than that side, it's not going to work. And this side is different than that side. So timesing each side by 2 is not going to work. That one you have to add all 4 sides together. Okay? And don't look at how I labeled that because that means something else too. Okay. For number 6, they want you to draw a diagonal and make that into 2 new shapes. What are those shapes? Draw a dotted line to make a diagonal, and instead of a rectangle, now we have 2 triangles. How do I find the area of a triangle? What's that formula for area of a triangle? Okay, I like the way you said that. The way we actually, us Northerners, us Yankees, we say it half base times height, which means the same thing as what you just said. Okay, she said length times width divided by 2. So let's take a look, and I'm actually kind of glad you said it like that. I'm going to move that over here for a minute. The formula we're used to seeing is 1/2 base times height. If we look at this triangle, this is our base. Do we know the length of that base? We don't know the length. And this is our height. Do we know the height? So do we have another strategy that we could use? Because that formula is not going to work. I don't have that information. But didn't I use length times width to find the area of the whole rectangle? What was the area of the whole rectangle? What was 8 times 9? Everybody? 72. So she said length times width and then 2 divided by 2. Because I cut it in half. So what's 72 divided by 2? 34? 36. 36 what? The area of that triangle is 36 what?
Units squared.
Very good. Units squared. And you're writing all of this down on your notes for number 6. Yes. Did we learn that yet? No. But if you know that, that would work. But unfortunately, most students don't know what that is. But if you use that, that would absolutely work. Yeah. I'm a little bit impressed. Yeah, very impressive. Very impressive that you know that. I'm afraid a few heads would explode if I tried to explain that right now. But if you want to discuss that further, come up to extra help one day and we can discuss that more if you want. All right, number 7, you're on your own. You ready? Got a little problem for you to solve. You are going to draw a rectangle on that brand new, nice, clean coordinate plane. However, each vertex, or vertices, however they word it, has to be in a different quadrant. Okay? So each corner or vertice has to be in a different quadrant. All sides have to be horizontal or vertical, which means no diagonals. Okay? Third thing is the perimeter has to equal 28 units. So with your pencil, try to sketch them out. And let's see what you come up with, and then we'll see some possible answers. Would that work? Can it be a square? Well, let's see. A square, all four sides have to be the same length. Is there a number that if we added it 4 times would equal 28? Is there a number that would work? 7. So it could be a square where each side equals 7. So now I want you to come up with something else. Yes? So would this square meet the qualifications? All 4 quadrants. I can move this down. I can move this over. I can move it anywhere I want as long as it stays with each vertice in each quadrant. But I want you to find something other than a square. Okay, so we could have had 13 and 1. A 13 by 1 rectangle would have worked. What else could we have had? We could have had a 12 by 2 rectangle. We could have had an 11 by 3 rectangle. A 10 by 4 rectangle. A 9 by 5 rectangle. 8 by 6 rectangle. And we already saw the 7 by 7 rectangle, which is a square. Now question, these all have a perimeter of 28. Do they all have the same areas? What's the area of a 13 by 1? Everybody? 13. What's the area of a 12 by 2? 24. What's the area of an 11 by 3? What would be the area of a 10 by 4? What would be the area of a 9 by 5? Area of an 8 by 6? Area of a 7 by 7? So all of those different rectangles have the same perimeter, but different areas. As our numbers got closer and closer together, our area was getting bigger and bigger. Because you'd have 13 plus 13 is 26, and then 1 is 27, and then 1 would be 28. That's right. That would not work because it would be sitting on an axis. I don't know if that's really 13. But then that would be sitting on an axis and it's not in a quadrant. So even if you did it that way. So that one would not work because you would not be in all 4 quadrants. Okay, you wanted to be in all 4, and unless you started doing halves. If you changed your scale on your x-axis or your y-axis, then it would work. Since this wasn't labeled, but if you went by units of 1, then 13 by 1 wouldn't work. But if you labeled this as 0.5 and 0.5, then it would have worked. Okay?